Okay, so today we're going to start our next unit on solving right angle triangles. So there's two different methods we can do to solve right angle triangles depending on the information you're given. We're either going to use the Pythagorean theorem or SOHCAHTOA, otherwise known as sine, cosine, tan. Today we're going to focus on Pythagorean theorem and tan, and tomorrow we'll worry about sine and cosine. So the Pythagorean theorem, you have to have a right angle triangle. And we've got two small sides, so we call them generally A and B. And then we have the longest side, which is C. So C is our longest side. It has the big long name of the hypotenuse. And Pythagorean theorem says that the longest side squared equals short side squared plus short side squared. And that's what we do. Okay, so let's try it. So here I've got two different triangles, and I'm going to solve for the missing length. So in the first one here, I have a short side, and I'm missing my long side. So this is the side we're looking for. Now, when we're dealing with triangles, remember we use capital letters for each vertex, and then the one across from it, we're going to start getting in the habit of using this lowercase letters. Okay, so this is the one we're looking for. But because I'm dealing with Pythagorean theorem, I can letter it however I want. I can call this one A, I can call this one B because they're both short sides, and the side that I'm missing is my hypotenuse, which is the longest side, which is C. So C squared equals A squared plus B squared. So the missing side that I am looking for is, let's see, that's going to be 13 squared plus B, which is 9. So we have to use our square button on our calculator. So let's see, 13 squared plus 9 squared. Add those all up first, 250. And then remember to get rid of our square. We have to square root both sides. So hit your square root button. And you should get a final answer of 15.8. Now this question didn't have any units. There should be units. So if I call this, I don't know, let's call it centimeters. Centimeters, then my final answer would be in centimeters. If this was feet, then it'd be feet. So you just got to be consistent. That's all. Let's look at B. So I haven't labeled B yet, but that's all right. Let's say I have a hypotenuse of, I don't know, 15 feet. And there's my right angle triangle. And I don't know, what's another good number? 8? Sure. Let's call this 8. So what's this side going to be? So since I haven't labeled anything, let's just call that one X. And then we look and we say, okay, all I'm dealing with are side lengths here. I can see that my longest side, well, that one has to be C. Short sides, it does not matter which one's A and which one's B. Just pick it. So there's A. Let's call that one B. Sure. Pythagorean theorem states C squared equals A squared plus B squared. So I'm going to stick in everything I know. So let's see. C is 15. So that's squared. A is the thing we don't know, plus B is the other side, so there's 8 squared. Okay, well, let's see. 15 squared, that's 225. X squared, we don't know. 8 squared is 64. Oh, well, we know how to solve that. Let's just minus 64 from both sides. So 225 minus 64 gives me 161 equals X squared. And then we know to get rid of a square, we just have to square root both sides. And my final answer is whatever the square root of 161 is, which is 12.68857. Oh my goodness. Yeah, we just need one decimal place here. So let's round that up to 7. And since this was feet, this will also be feet. Okay, good. So a lot of our questions involve Pythagorean theorem sometimes shows up, and you just have to know how to use it. So hopefully that's review. If not, there you go. There is a special triangle, and this gets used a lot in construction, actually. And this is the 1, 1, 2 triangle. So there's a 1, there's a 1. So when I've got triangles that are both the same side, remember that's an isosceles triangle. So when I've got two same sides, it's an isosceles, which means that this angle and this angle must also be equal. These angles are equal. And it's called a 1, 1 root 2. Let's just use Pythagoras on this. Let's just figure it out. So the longest side is c, little side, little side. So Pythagoras says c squared equals a squared plus b squared. So longest side equals 1 squared plus 1 squared. So let's add those up. 1 squared is 1, 1 squared is 1, 1 plus 1 is 2. Get rid of my square here. And we can just leave it as a root 2. That's fine. So this gets used a lot in construction. There's a very important reason why. And that has to do with the angles. So to figure out these angles, when I know the two different short sides, well, I need another tool. So I need the tan ratio. So the tan ratio talks about a specific, so we have one of our specific little acute angles. And the side adjacent to that is our big A, so adjacent. Opposite to that, we use our big letter O for opposite. Okay. We use our big letter H for hypotenuse. But the hypotenuse has nothing to do with tan. The tan ratio says tan of my angle is opposite over adjacent. This is where I get T opposite adjacent. Okay, so that means tan of my angle is the side length opposite divided by the side length of the adjacent side. Adjacent side. Okay, and what does this even mean? Well, back before they had scientific calculators that had all this stuff stored in it, well, you'd have to go on the computer, or not on the computer, you'd have to go to a book and look up the table. Where's my table here? I had a table. There it is. Trig tables. So what they are, sine, cosine, tan, they're just ratios of side lengths. And each one of those ratios corresponds with a specific angle. So you'll actually see a lot of these printed on books that people take into the field. So field tech, surveyors, that sort of thing. You'll actually see this a lot because they'll refer back to it because specific angles have specific ratios. Okay, so what does that mean for us? Well, the tan specific ratio deals with the opposite side and the adjacent side. So let's put this into effect here. So let's write the tan ratio for this acute angle. So if I look at x, if angle x is what I'm interested in, then that means my opposite angle is all the way over here. My adjacent angle is touching over here. And I don't care about the other side because it's my longest side. So tan angle is opposite over adjacent. So in this case, tan x is opposite over adjacent. So tan x is opposite over adjacent. And that's what we mean by a tangent ratio. And what that means is that if I had a similar triangle, so a scale diagram, I don't know, so let's make it twice as big. Okay. So if I made this side down here, let's make it twice as big. So 6 times 2 is 12. 12 times 2 is 24. Well, the cool thing is that this angle is still going to be the same as this angle because they're just multiples of each other, which is really cool because 6 divided by 12, well, that's just a half. Let's figure this one out. Tan of, let's just call it theta, opposite over adjacent. Well, tan of my opposite here is 12. My adjacent is 24. Well, that's just 0.5. So that's really cool. And that's where these relationships come into play. That's where these ratios matter because they're just scale multiples of each other as long as those angles stay the same. So what does this mean? The value of the tangent ratio is usually expressed as a decimal that compares the lengths of sides. So for here, tan A, if it was equal to 1.5, then any similar right triangle, so any multiple of it, means that this side is going to be 1.5 times this side. And that's the power of these ratios. Okay? So when they ask you to write the tan ratio, you're just writing the fraction of the two sides because that's the multiple of it. let's do some solving here. So let's do, whoops. Let's do this one here, where we want to find a side length here. So let's give this an angle of, I don't know, let's call that 30 degrees. Let's say this has a side length of 5 centimeters, and I want to figure that one out. So because I'm dealing with a small angle here, the side that it's touching is my adjacent. Okay, so that's my big A. The side that's all the way over here is my opposite. So that's my O. So I'm dealing with opposite and adjacent. I'm dealing with tan, right? Tan, opposite, adjacent. So tan angle is opposite over adjacent. So I'm just going to stick in what I know. So 30 degrees is the angle that I'm talking about here. Opposite is my X. Adjacent is my 5. And all of a sudden now I have a one-step equation. So to get X all by himself, I'm going to have to multiply both sides by 5. And now I know that X is going to be 5 times tan 30 degrees. Make sure your calculator's in degrees mode, please. So we might have to cover that in class for everybody's different calculators. So 5 times tan of 30 should give me a side length of round that up, 2.9 centimeters. So any 30-degree triangle is going to have that same relationship between them. In this case, because this side length was 5, this opposite side is going to be 2.9. Now I can use my tan ratio also to find an angle. So let's make, it doesn't really matter, let's say this one. Let's solve for angle G. Okay, so that's going to be the angle that I'm looking for. I like to use the little theta. You can use the G, I don't care. So I'm going to use tan as opposite over adjacent. I'm going to use that because this side is the small side touching the angle, so that's my adjacent. This side is opposite, so it's all the way over here. So there's my opposite. So since I have a number for adjacent, I have a number for opposite. I can sub these in and solve. So tan of my angle is opposite is 4, adjacent is 5. So tan of my angle, 4 divided by 5 gives me a 0.8. Now, how do we get our angle all by ourselves? So this is where you have to use your second function on your calculator. So above tan, so you'll have your button with your tan. Oops. Okay, there's my button. Up above it, you generally see a tan with a -1. So to get there, you have to push your second function to get to it. So to get my angle all by itself, I need to get tan -1, so tan inverse, 0.8. Okay, so that's called tan inverse. And that's how we have to type it into our calculators. So I'm going to want second function tan to get my tan -1 should show up. 0.8 equals, well, now that's told me that I now have an angle of 38.7, rounded up, degrees. So we've got tan we can use to solve for a side length. Oops. If I know the angle, and I can use it to solve for an angle if I know my side lengths. Okay. So it's not just for math class. Construction uses tan, trig, all of it, constantly. So here I have a scenario. The latitude of Fort Smith, Northwest Territories is approximately 60 degrees. Okay, there's geography for you. Determine whether this design for a solar panel is the best for Fort Smith. So I have a house. Now, I don't know about you, but going and climbing up on a roof to measure that is not easy. But I can definitely measure a vertical, and I can measure the horizontal. So those are easy to do. Now, the thing about solar panels is they work best when the angle of inclination, so the angle that the slope makes, so the angle between the roof and the horizontal is approximately equal to the latitude of the house. Isn't that neat? Trig in real life. So when an architect designs a house that's going to have solar panels on its roof, the architect has to determine the width and the height of the roof, so the width of the roof and the height of the roof, to make sure that the panels are going to work efficiently. So let's do this and let's solve and figure it out. So I've just decided that, or sorry, the scenario has provided me with this house. And I need to know if this angle in here, so this angle of inclination, I have to figure that out and then compare it to see if it's 60 degrees. So there's my right angle. So if that's my little angle, then my adjacent is the one that's right beside it. Opposite is all the way over here. And because I'm dealing with opposite and adjacent, that means I'm dealing with the ratio tan angle is opposite over adjacent. So let's put in what I know. I don't know my angle, right? That's what I'm trying to find. Opposite is 9. Adjacent is 12. So if I go to figure that out, 9 divided by 12, well, what's that? 9 divided by 12 is 0.75. But I want to figure out the angle. So that means I'm going to need to do the inverse. So the second function. So I have to type into my calculator, second tan 0.75 equals 36.9 degrees. So if that's the angle that this roof is making, I don't think this is going to make for a good solar panel because it's definitely not a 60-degree angle. So therefore, this roof is not suitable for solar panels unless you have a better frame, unless you set up a frame for your panels. And that frame would have to be angled probably at about 60 degrees. Again, you're going to want to use Trig for that. So isn't that neat? Trig in real life. So let's come back to this special triangle, this 1, 1, root 2 triangle I was talking about. So I said again that this is a really important one for construction. And let's figure that out. So in this 1, 1 triangle, I know this side length, I know that side length. So let's figure out what our angle is. So I can use tan, angle of opposite over adjacent, because over here is my opposite, touching it is my adjacent, okay? So I need to figure out the angle of this 1 over 1. Oh, well, 1 divided by 1 is just 1, right? To figure out my angle, I have to bring tan to the other side, so I have to do my inverse. So my angle is going to be equal to tan inverse of 1. And if you type that into your calculator, well, let's see, second function tan of 1 equals, 45 degrees. Oh. So the 1, 1, root 2 triangle is a 45-degree triangle. So that's really handy. And why is that handy? Well, if I went to go, I don't know, design a door, right? There's my door. There's my doorknob. And I wanted to put a frame around the door, and maybe I wanted to make a nice angle there. Well, I would want 45-degree angles. And it's real easy to measure same side triangles. And then I've got my 45 degrees. I actually did that when I was building my house, and it worked out perfect. Trig in real life.